Hello and welcome to part 5 of An Idiot Explains the Universe. In this episode, I would like to explore what matter is. This subject has never come up in any conversations I've partaken in during all my 45 years of existence. Nobody cares what matter is. But that don't matter to this idiot. I'm spending a substantial amount of time writing a script and putting together a video about a topic that literally nobody has ever expressed an interest in, and I'm doing it all for the sake of attention. I mean science. Let's get started, shall we? If we zoom in 621 miles on this whiteboard, we will eventually come across molecules. Molecules are really amazing and should be the most trending topic on every social media platform. Molecules are made when two or more atoms chemically bond together. It's how they bond together that's the amazing part, which I'm not going to get into. You're just going to have to trust me. Let's travel a bit further. Let's say 6,210 more miles to be exact. We will come in contact with an individual atom. Atoms are great because these little guys are responsible for storing, transferring, and transforming energy with the help of the fine structure constant, which I talked about in my last video. But let's not end there. Let's travel further down into the atom's nucleus. To do this, we would need to travel 62 million more miles to reach it. That's the same distance it takes to wrap around Earth 2,490 times. The nucleus of an atom contains protons and neutrons, collectively called nucleons. Protons are positively charged particles, while neutrons have no charge. Together, they account for nearly all of an atom's mass. If we zoom in an additional 12 million miles, we can just make out the individual protons and neutrons. But let's not end there. I'm too far deep in the hole now. I can't stop. Here's where things get nuclear. If we wanted to see inside a proton or neutron, we would need to travel 520 billion more miles, equivalent to traveling from Earth to Pluto and back again 46 times. And if you convert that to USD, you'll still not have as much money as Elon. Each proton and neutron are composed of 3 quarks bound together by particles called gluons, which mediate the strong nuclear force. Gluons are not physical matter, they are pure energy. The strong nuclear force is one of the 4 fundamental forces of nature. Therefore, you cannot zoom in any further unless you want to create a micro black hole. But we can learn about these forces by going back in time to the beginning, back to the Planck era, when the universe was so hot and dense that it made P. Diddy's freak-offs look like a knitting circle at a retirement home. According to the Big Bang Theory, everything that exists today also existed at the beginning of time, during the Planck era. This included us and also aliens from other planets. It includes all the people and all the aliens that haven't even been born yet. And we should all be held accountable for our actions during this first original sinful moment. During the Planck era, the 4 fundamental forces were unified into a single force. These 4 fundamental forces include gravity, electromagnetism, the weak force, and the strong force. Everything in existence was percolating inside the belly of this unified pregnant force. In a micro, nano, almost non-existent second later came the grand unification era. As the universe expanded and cooled, the unified pregnant force gave birth to the strong nuclear force during a process called symmetry breaking. Thus, gluons and quarks began to take shape inside a high-energy quantum soup. In a micro-nano, almost non-existent second later, came the quark-gluon plasma era. Quarks and gluons existed freely in a dense, hot state known as a quark-gluon plasma. This plasma made P. Diddy's freak-offs look like a church potluck on a Sunday afternoon. After a micro-nano, almost non-existent second later, came the hadron formation era. As the universe cooled further, quarks combined to form hadrons such as protons and neutrons. During this era, gluons mediated the strong nuclear force, ensuring that quarks remained confined within these hadrons. I would say that this era in particular was a different level of freaky, the bondage kind of freaky. This era makes the P. Diddy freak-offs look like a middle school dance with the lights on. You want to hear something really freaky? Since the strong nuclear force can't be separated from quarks or gluons, what came first? The strong nuclear force or the quarks and the gluons? Surprisingly, the strong nuclear force came first, but in the form of a concept. What? Seriously? But yes. It existed before quarks and gluons in a conceptual form of existence, whatever that means. I don't know. Do you guys know? I need help understanding this. Let's talk it out. The strong nuclear force derives its strength and behavior on the properties of quarks and gluons. So how could it be anything at all without quarks and gluons? That's my question. And get this, the strong nuclear force tells quarks who they can and can't be friends with, all to ensure that only the most demure, acceptable babies are produced, such as protons and neutrons. Gluons act as a strict mediator, overseeing the strong nuclear force, making sure it doesn't mess up. So the strong nuclear force uses brute strength for arranging forced marriages between quarks, while the gluons slap each other silly whenever the strong force can't find a match. The gluons slap each other until the right match is found. If that's not love, then I don't know what is. I'm not making this stuff up, guys. It's real. It's stranger than fiction. The strength of the strong nuclear force increases as quarks move farther apart. This is due to a property called confinement. At short distances, the force weakens, allowing quarks to move freely inside protons and neutrons, so they can hook up, basically. At longer distances, the force becomes so strong that quarks cannot be separated from inside the hadron. Instead, pulling quarks apart creates new quark-antiquark pairs, forming new particles. That's like separating P. Diddy from a freak-off, only to get another P. Diddy and another freak-off. The strong nuclear force is confined to quarks and gluons, but its force is so strong that it radiates out to the actual nucleus, which means this force is equivalent to the span of 100 million square miles. This force is what holds the nucleus together, and yeah, it's pretty strong. If it were any stronger or any weaker, we wouldn't be here! I'm supposed to be telling you what matter is, but here I went down the rabbit hole hard this time. So hard that it makes a P. Diddy freak-off look like a PTA meeting with juice boxes and string cheese. Let me try again. Okay, we got molecules. We zoom in to see atoms, zoom in again to see the nucleus, cover approximately 1.06 trillion miles in doing so, which is equivalent to 180 light years, which, if we traveled 180 light years with our most advanced Parker solar probe, it would take us 281,250 years for us to shrink down small enough to see the nucleus of an atom. But here's the thing. literally the only thing I actually wanted to tell you about in this video. Of those 1.06 trillion miles that we have to travel to reach the nucleus of an atom, only 10.6 million of those miles consist of a form of physical matter, which leaves 1.05999 trillion miles of empty space. 99.9999% is empty. This is equivalent to 1 grain of sand on a football field. The grain of sand is matter, while everything else resembles empty space. Electrons are in this empty space, zooming around, causing energy, light, color, basically acting like golden retrievers with ADHD wanting our attention. But these golden retrievers are so small that their physical matter is negligent, non-existent to the point where they don't even register as a blip. They have enough combined energy to tickle our senses enough for our brains to evolve around their need for attention, and yet they mean nothing without our perception. These golden retrievers aren't even part of the grain of sand on the football field.
How do you explain this?
As for the truth of physical matter, well, let me just tell you this. Nothing actually touches. Yes, that's right. You heard correctly. All those P. Diddy freak-offs were celebrations of our ability to never physically touch one another. This holds true even for Homelander, punching the heart out of some poor schlepp's chest. Don't you believe me? Well, truthfully, that's not even the unbelievable part. But yes, it's 100% true. Physical touch is impossible, and you know what? If we were to physically touch, you know what would happen?
We would explode. We'd explode.
Let's roll up our sleeves and get down and dirty. Or as Will Smith would put it, get jiggy with it.
What are you saying, Vagabond Mel? Why can't we touch?
Well, I'm glad you asked. And here is my magic whiteboard that could tell you all the answers you seek. At the atomic level, matter is composed of atoms that contain a dense nucleus surrounded by negatively charged electrons. When you bring your hand close to an object, the electrons in your hand and the object's surface repel each other because they carry the same negative charge. This repulsion creates the sensation of touch, but no two atoms actually touch. The Pauli exclusion principle. This principle states that no two electrons can occupy the same quantum state in the same space. This means that the atomic structures of your hand and the quantum structures of the object form a kind of invisible barrier that prevents their electrons from intertwining and merging. When you feel something, it's actually your nerves responding to those electromagnetic interactions. The forces created by the repelling electrons exert a pressure on your skin which is picked up by specialized nerve endings called mechanoreceptors. Mechanoreceptors. Your brain interprets these signals as touch. Even though it seems like you're touching something, there's always a minuscule gap between your atoms and the atoms of the object, on the order of a few, I don't know this word, angstroms. Angstroms. And that's a billionth of a meter. So while it feels like contact, the touch you experience is really the result of electromagnetic interactions and not the physical fusion of matter.
I can't do this anymore. I feel so isolated.
Atoms are mostly empty space. The nucleus occupies a tiny fraction of the atom, and the rest is an electron cloud. The Casimir effect. This is something cool I learned about years ago, the Casimir effect. It's proof that Heisenberg's uncertainty principle is applicable in nature. Way back in 1927, before the technology was invented to prove his theories, Heisenberg hypothesized that we cannot know both the position of a particle and its momentum. We can know either one or the other, but not both simultaneously, partly because a simple act of observation will disrupt these quantum systems. The Casimir effect is proof that infinite possibilities exist in an empty vacuum of space. Now that you know a little bit about Heisenberg's uncertainty principle, let's apply it to the Casimir effect. Picture in your mind two plates. No, not those kind of plates, but conducting plates that are extremely smooth and flat. If you stack them together, the sheer force of virtual particles popping in and out of existence will outnumber those that are between the plates, thereby pushing the plates closer and closer together, like a magnet, even though magnets have nothing to do with this. They are being pushed together similar to that of a cheap submarine that will implode if submerged too deep. The surrounding pressure is greater than that of the inside. You can also think of it as proof of an interconnected ether. Unfortunately, it is very hard to prove that we live amongst an ether. If an ether permeates all things, then there is nothing to compare it to. There's no measurements that can be made, no friction, no contrasts. Just like a fish not knowing what water is, how could they know what water is until they escape the tank? But yeah, there might be an ether. It would explain some things. Back to the plates. These plates still never actually touch, thanks to atoms and their ability at pushing objects away. If you're ever doubting the weird world of quantum mechanics, it's things like the Casimir effect that can erase all doubt. Yes, there are quantum fields of weirdness, and yes, they have been proven to exist. Here is another fun little brain tickler. Since we're on the topic of matter, a Bose-Einstein condensate. Like I said in all my other videos, space can't exist without time. Time can't exist without space. Space can't exist without energy, and vice versa. I bring this up at least once in all my videos. And well, here it is again. Today's mention is brought to you by the Bose-Einstein condensate. First theorized way back in 1924, before they could prove their theory, Einstein and Bose hypothesized that when a collection of particles are cooled to very close to absolute zero, they begin to behave in a collective unified way, as in a macroscopic quantum state. This, according to me, happens because once movement slows down enough to the point where it can no longer emit energy, time ceases to exist. To me, time can only exist as long as entropy exists, and if there is no entropy, there is no time. Without time, spatial dimensions are lost, and so we get our very first proven macroscopic quantum state of matter, first proven in 1995, only 71 years after its conception. Essentially, all the frozen particles merge into one single superatom, and since this superatom exhibits very slow entropy, there is very little friction to slow it down. It's considered a superfluid. These Bose-Einstein condensates, BACs for short, might someday help in developing quantum computers. Let's summarize today's episode to solidify all that you learned about the wacky world of matter. If we extracted all the empty space from our bodies, what remained would be the size of a particle of lead dust. If we did this to the entire human race, we could all fit inside a sugar cube. On a much grander scale, if we vacuumed out all the empty space in the observable universe, we would be left with enough matter that can fill 428 quadrillion suns, which sounds like a lot, but it's not as mind-blowing as the insignificance of the human race's sugar cube. But I thought it was a cool enough fact to include in this video. We are mostly empty space, and we never actually touch anything. We only detect the pressure caused by wavelengths trying to push us away in order for our electron clouds to stay separate from each other, because God forbid will either explode or meld together if we didn't repel things. If we didn't repel things, at the end of a P. Diddy's freak-off, all of its participants would be one gelatinous glob of arms and legs slathered in baby oil.
That's not a nightmare, it's science.
If we are nothing more than a particle of lead dust, then what are we? We are quite literally frequencies. Yes, we are. What? You don't believe me? Are you not vibing me, bro? We only know as much as our brains allow us to know. What we see with our eyes might not be the true reality that's out there. In the real world, beyond our senses and imagination, measurements don't exist. There are no meters, seconds, pounds, or volts. They don't exist in nature. They exist only in our minds, in how we perceive. There might be a slew of other stuff going on that we are unable to perceive because, well, if we're truly living amongst the infinite, then whatever is able to exist will exist. In my next video, I would like to discuss energy and how it might be interdimensional. This is just my own personal theory, but it's rooted in science. Since energy can warp the fabric of space-time, I'm keen to believe that energy is deeply entwined with space itself. As I have mentioned again and again, you can't have space without energy.
Until next time, quantum quackers, stay open and amazed.